Since we will be evaluating science and scientific claims in this class, we need to be able to speak science. Scientists have their own words, which we call jargon, and they have a specific uniform way that they measure data. This uniform and specific way of measuring data is called scientific units, or SI, and it uses the metric system. The reason that we do this is also the reason that we use the Western Arabic numbering system in math. It's because everyone uses it. It's universal. If I measure my height, right, as 5 feet 6 inches, you would know what I'm talking about here in the US. But if I was talking to a scientist in Kazakhstan, she wouldn't be able to immediately approximate my height, right? But if I told her I was 167.64 centimeters tall, she'd know instantly, right? And that's because the metric system is universal, just like the Western Arabic system. In fact, our way of measuring things in the US is called the imperial system, and it is really only used here in the US and in Liberia and Myanmar. And both Liberia and Myanmar are phasing it out in favor of metric system. Okay, so one of the reasons that the scientific community has decided on using metric is because it is base 10. This means that the number 10 is used as the base unit, and each time you multiply that base unit by a factor of 10, you get a prefix on your unit. Okay, so in other words, the metric unit has a base unit, and then any prefixes are multiples of 10. Okay, so if you have your base unit and you multiply it by 10, then you say it is a deca unit. Or if you multiply it by 1,000, it's a kilo unit. Does that make sense? Okay, so imperial measurements, on the other hand, do not have a uniform base. Okay, there's 0.625 ounces in a tablespoon and 0.07 tablespoons in a cup and 16 cups in a gallon. So converting between all these crazy units is hard, and it's hard to remember that you can measure liquid volume in ounces, tablespoons, quarts, gallons, cups, pints, and drams. Okay, don't even get me started on inches, yards, feet, and miles. All right, it just makes my head hurt. In SI, or metric units, there's only 1 unit of length or in 1 unit of distance, right, which is meters. There is no other unit, only meters. Mass or weight is always in grams, okay? You don't have to start worrying about all of these other crazy measuring units. And remember, you can always scale up or down to kilograms or milligrams, but it's all still just grams. Oh, it's just so nice and neat and tidy and so much easier. So hopefully I've sold you on SI, but what happens if in our life some crazy person gives us a confusing imperial measurement? Well, then we use our handy dandy conversion equations. It's math, but it's so simple, so don't be scared. The scary part is the imperial unit, trust me. Okay, so what do? First, we need to find our conversion factor, and we'll use a metric conversion chart or a metric conversion table for this. And here it is. We know that there are 0.45 kilograms in 1 pound. So we can figure out how many kilograms are in 14 pounds and then scale down, or scale to gram from kilograms. Excuse me. Okay, so step 1, we want to turn the conversion information into a ratio with the imperial unit in the denominator. This is important, okay? Imperial units go in the denominator. So in this case, it would be 0.45 kilograms per pound. Okay, now we multiply that ratio by the imperial measurement that we were given. But before we calculate, we really want to make sure that the units cancel out properly and that we're left with the right units. So pounds divided by pounds cancels out, and we're only left with kilograms, which is metric. So far, so good. And this is why you really wanted to make sure that the imperial was in the denominator. Now, If our conversion ratio was upside down, we'd get a totally weird unit like this, pounds squared per kilogram, which is a really strange mix of metric and imperial and completely confusing and wrong. Metric is not confusing. If you get confused, then it's not right. Okay, so now that our units are correct, we calculate. 14 times 0.45 is 6.3. Now we have the kilograms that we wanted, right? But actually we didn't want kilograms, we wanted grams. Well, converting between those is easy, right? Because a kilogram is just 1,000 grams. So we can use another super easy conversion, okay? So remember, you want to put the unit that you need to end up with as the numerator and the unit you're trying to get rid of as the denominator. Okay, so we do that. 6.3 kilograms divided by 1,000 kilograms is going to get us 0.0063 grams. And that's all there is to it. So put a box on your answer and make sure you turn in all your work. In fact, this whole bit right here that says full credit answer is what you need to turn in for full credit on a conversion problem like this. Now, the only kind of weird conversion is temperature. When you're converting Fahrenheit to Celsius, you want to use this formula. So I'll work through this conversion for you too. This is really just a plug and chug affair. We have our temperature in Fahrenheit, so we just put that into the equation and solve. All right, and then after we solve it, we put a box on our answer and we turn it in. Okay, I hope that has helped you.